So in the previous lecture, we have seen the pressure due to the atmosphere, right? And we use the barometer to measure the atmospheric pressure, and the atmospheric pressure values in terms of uh, mercury column, it is 76 centimeter of Hg. You will write, right? The barometer is used, and the gauge pressure and the absolute pressure definition we have given. Also, we have seen the variation in pressure due to the height, right? Due to the depth. So now the variation in pressure due to accelerating fluid, accelerated due to in pressure in accelerated fuel, right? What does it mean? Listen one thing. If this is the vessel and the water is filled, suppose, or the liquid is filled, so if we move down, right, if you consider the water is filled right here, and you consider this the cylinder, right, at this point 1 and this point 2, this is the height h. Are you getting or not? So the P2 is greater than P1 by value h rho g. It is clear, right? Or P2 minus P1 is equal to what? Say h rho g. Delta P pressure is equal to h rho g. It depends upon the height, right, between the 2 points, density of the liquid, and the acceleration due to gravity. If this acceleration due to gravity decreases, the change in pressure decreases. Is it clear or not? That is the thing. If this liquid is accelerated, suppose this is the lift, right, and this is the tank, and the water is filled over here, and suppose this lift is accelerating in upward direction, right, and now you are sitting over here, and you consider the 2 point P1 and P2, right, P1 and P2 at the separation H. So what is the difference? Then P2 minus P1 will be equal to H rho and G effective in this case. So therefore, if lift is accelerated, the pressure difference will be equal to the G effective will be equal to G plus A. I think you know this very well. Is it clear or not? So the inside the lift, and if it is accelerating upward, this is the lift accelerating upward with acceleration A, the change in pressure varies like this. In the same way, listen one thing. If the lift is there and there is a tank, suppose the water is filled over here and it is coming down, this is the P1 and P2, the 2 points are separated by distance h, right? If it is coming down, the separated by h, what is the pressure difference? P2 minus P1 is equal to h rho G effective. In this case, G effective will be equal to, right, rho G minus A. Is it clear or not? Tell me. H rho G minus A. But if this lift is freely falling, right, if A become equal to Z, that is, if this is the lift and it is freely falling, acceleration to G, then if you consider the fluid and any 2 point consider over here, 1 and 2, do you understand or not? So what is the pressure difference between this? So delta P is equal to H rho and G effective G minus G. Here the acceleration become equal to what? G minus A, G minus G, and no pressure difference. It means all the pressure are the same pressure, right? Equal pressure points, every points are there. So the pressure difference basically due to the acceleration due to the gravity. If somewhere, for example, in the satellite, the no G effective in the satellite is 0. So between the 2 points, there will be no potential, no pressure difference. Is it clear or not? Varsha, copy this. So here I will ask you what is the equal pressure line? Equal pressure lines. What is the equal pressure lines mean? Listen one thing. If you are sitting on this tank, the water is filled, and you consider water molecules, right, and it is at rest. So can you tell me what is the force is acting on the water molecule? If only the water molecule you consider in air, you tell me what is the force is acting? Only the mg force is acting. Is it clear or not? The mg force is acting. Mg force. So the mg force is acting, and listen one thing, on the same horizontal line, the pressure will be the same. The pressure will be the same. Whatever the point you consider here, the resultant force on the surface is acting on every surface in this way. Is it fine or not? Like this. That is why the surface of this water level is what? Is horizontal. And these are the equipressure line. If this is the P1, P2, so every point the pressure is P2. If this is P3, if this is P4, like this. So at every point the pressures are same. If it is at rest or moving up or accelerating up or down, right, like this, up or down. For example, if it is moving up, this is the equipressure line over here. You can make these. This is the very important, right? If this is the pressure P1, this is the pressure P3, this is the pressure P4, so this is the pressure P2. And the surface, if it is open, suppose it is open, the surface will be of the liquid will be the horizontal. In the same way, in this case also, right, these are the equipressure line. These are the equipressure line. Although in this case the pressure, as we are moving up, listen one thing, very important thing to understand this. If you are sitting on this tank and if you consider a point, a particle, right, single particle, right, suppose this is the drop. So what is the force is acting on this? If this is accelerating, mg plus a. So this is the g plus g effective, right? So the pressure will be changed, pressure will be increasing by depth h rho, and the acceleration. Whatever the acceleration is, so the acceleration value will come over here. In this case, if you are sitting over here, consider a drop. So what is the force is acting? Say mg minus a. So in this direction the force is acting, and in this direction the pressure is increasing by what amount? H rho. What is H? H is the distance between the 2 points, and G effective is the G minus A. Is it clear or not? These are the equipressure line. Now suppose the liquid move horizontally, right? Horizontal accelerated fluid, right? Horizontal accelerated fluid. Suppose this is the tank, right? And initially the water is at rest or it is moving with constant velocity. Are you getting or not? If you are sitting over here, right, what force will act? Say only mg. Is it clear or not? Now if this fluid start accelerating in the horizontal direction, so when you are sitting, if you consider a point mass, with respect to this is the non-inertial frame, this is the non-inertial frame, so therefore mg plus a acting. So tell me how many force will act? Say mg will be acting downward direction, and if its acceleration is right, so the pseudo force will be acting, say ma. Are you getting? Now therefore the pressure will change when you move down. It will increase due to the mg, and it will increase to the left also due to the ma force ma. In this case only the mg or mga plus a acting. So no horizontal force was acting on the water molecule. Therefore in this case the surface, the equipressure lines are horizontals, right? These are the equipressure lines are horizontal. But in this case, what is the resultant force on this molecule? You tell. The resultant force will be in this direction. So therefore the resultant force will be acting in this direction, and you will see, right, the equipressure line, when you will sit, the equipressure line become like this, because the net resultant force will be in this direction. Whose resultant is this? Mg and of Ma. So the net resultant force acting on the body is in this direction. Therefore, the surface in the horizontal accelerated fluid become tilt, or it makes some angle with the horizontal. Is it clear? What is the angle? I will explain. First, copy this. So, as I told you, in which net force, here the net force is acting in this direction, so the pressure is acting in this direction only. But if you consider this is the case, right? So the net force is acting in this direction. So in the in the horizontal accelerated right liquid, the equipressure line will be like this. These are the equipressure lines. These are the equipressure lines. Is it clear or not? These are the equipressure lines. These are the equipressure lines. Equipressure lines, equipressure lines, equipressure lines. So the pressure is increasing in this way. All the point, the pressure is what? Same. Right? Although it is air, what is the pressure at this point? Say atmospheric pressure, no doubt. And if you consider this line, the pressure at all the points will be equal to the P1, P2, P2, P1, 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 P1. Is it fine or not? Varshas. And the net force will be acting. In this case, the net force is acting in this direction. So that is why the pressure is increasing. The net force will be acting in this direction. And what is the net force? The resultant of mg. If you consider this is the any point you consider. This is the mg and this is the ma. Right? And this is the perpendicular. So can you tell me what is the angle? Yes, the angle I can make. If this is theta, this is also theta. This is 90 minus theta, this is theta. So what is the theta? This is ma and this is the mg. Right. So tan theta is equal to what? Tan theta is equal to ma upon mg. And this is the angle made by the surface with the horizontal. So acceleration, so this is what? Tan theta is equal to, tell me, a by g. So theta is the angle made by the horizontal with this equipressure lines. These are the equipressure lines. Is it fine or not? You tell me. And the pressure is increasing like this. So you tell me at which point the maximum pressure is over there. At point A, at point B, at point C, at point D. Tell me. At point C, the maximum pressure is at point C. What about the relation between the pressure at A and B, A and D? You tell. Pressure relation between pressure A and pressure D are equal. You understand or not? Is it clear? Right, very good. Listen, one more thing. In this question, suppose this is the, listen, it was the case when the upper side was open. If you fix and it is at rest, it is full of water, right? If it was open, when it accelerate, if it is open, it will accelerate, some fluid will come out and it become, the shape become like this. But suppose the tank is covered and no water can move out from it. Is it clear or not? So what will be the surfaces of the liquid? They will horizontal. They will be at some angle in this way only when it is open, right? And if it is closed, the surface will be the horizontal only. Is it clear or not? But still the equipressure line will be like this. Why it is so? Because the net force acting in this direction. What is the net force? Say this is the ma, this is the mg. So these are the net force direction. Are you getting or not? and these are the EQ pressure lines. These are EQ pressure lines, EQ pressure line, EQ pressure line, EQ pressure line. So if you consider this the P1, P2, P3, P4, like, and this is the P5, this is the P6. So where the pressure, if you consider A, B, C, and this is the D. Is it clear or not? You tell. Varsha, the pressure, minimum pressure, where will be the minimum pressure? Say at A. Is it clear? The pressure is increasing in this direction along the net resultant force, and these are the EQ pressure lines. Very important question, right? Concept. EQ pressure lines. Then after that, point D is greater or point B is greater? No. This is the line which is passing through the B. This is the line which is passing through the D. As shown in figure, please tell. Yes, D is less, right? And then B is increasing. This point is increasing. Is it clear? And maximum pressure is at C. You understand this question or not? Although the surface is horizontal, but these are the EQ pressure lines. In this case, it is open, so water comes out from the back side, right? And it become like this. You understand this thing or not? Sometimes they ask the question, right? If it is filled with water, right, and it is accelerating in this case, right? Example. If you consider the 2 points P1 and P2, you tell me, and the separation between them is L. What is the pressure? Which pressure is greater? Whether P1 is equal to P2, P1 is greater than P2, P1 is less than P2. Which is correct? P1 is greater than P2 or P1 equal to P2? Repeat. P1 is equal to P2. Listen one thing, very important thing. It is accelerating fluid, right? And when it is at rest, right? Whether surface is open or not, it does not matter. Whether surface is closed or not, you have to see the EQ pressure line. In this case, the EQ pressure lines are these. When the EQ pressure lines are horizontal, the pressures on the horizontal surfaces are same. Is it clear or not? But it is accelerating fluid. What type of the EQ pressure? These are not the EQ pressure line, and this is not the correct answer. Let me check. Did you make the EQ pressure lines? How they will be formed? Again, if it is accelerating in this direction, so EQ pressure line will be like this. Now tell me which is greater. Repeat. These are the EQ pressure lines. The pressure is increasing. P1 is greater. Although they are same horizontal point. So what is the difference between the yesterday concept? Yesterday I told on the same horizontal level, the pressure is same. But in this case, they are on the same horizontal level. Still, P1 is greater than P2. Why? Because the pressure is increasing in this direction. Why the pressure is increasing in this direction? You tell. Because net force is acting in this direction on any point. On all the point, net force. What is the net force? Root over ma square plus mg square is acting. I'm not writing that, right? So that is why the net force is acting in this, increasing in this direction. If the force is increasing in this direction, the pressure will increase in this direction. So which is correct option? You tell. P1 is greater than. If it is greater than P1 is greater than P2, then what is the value of P1 is greater than P2? I will explain. First copy this.
Sir, I have a doubt.
Yes, please.
When it is accelerated in a closed container, the orientation of the fluid changes or
No, orientation of the fluid, how can it be changed? Because it is constrained to to remain in this case. Although the water molecule will be in this way, but if it is at rest, suppose I'm making a small figure, suppose this is the water and it is full and it is closed. If it is at rest, the thing is that only the mg force is acting on each molecule in this direction. But if it is accelerating with A, you tell me, you have to sit on this frame of reference and the mg and ma in this direction. This is the mg downward, ma. So net force start acting in this direction, but the molecule will remain like this. The molecule will remain right like this as it is. Only the difference is what? In this case, these are the equipressure line because the force is acting in this direction. So the perpendicular lines are the equipressure lines. Now the force is acting in this direction. So the perpendicular to this resultant force, they will be the equipressure lines. The water will be full. But if suppose this is open, if this is closed, it will remain as it is. If it is open, what will happen? When you accelerate, the force start acting in this way. So when the force start acting with this, some extra fluid will come out from the trolley. Is it clear or not? You can check this. You fill the water container and sit with you on the back of the scooty. When you will and open the upside, so when you will move or accelerate it, the water will come out from the right vessel. Is it clear or not? Right, that is the thing. Copy this.
So then in that example you gave, if the container is open,
Yes, if it is open, then the water will become like this. If it is open.
P2 will be greater than
No. It's still. Whether it is open or whether it is closed, right? It is accelerating, the net force is still acting in this way. Is it clear or not? So the same thing. This is the same pressure. Then this is the same pressure. This is the same pressure. If it is open or it is closed, these are the equipressure lines. The pressure will varies in this direction. If it is open, the atmospheric pressure start exerting on this point, and then pressure will increase. Is it clear or not? Right. And if it is closed, the pressure will increase perpendicular to this net force direction. Is it fine or not? Right. Now our work, if you consider this the open, right, I'm marking this. Suppose this is the P point and this is Q point. Now tell me, which is greater, which pressure is greater? Suppose this is the Q on this line, P is on this line. Tell me, which pressure is greater? Yes, pressure of P is greater than pressure of Q, whether it is open or not, because this is the equipressure line. Line has the same pressure. Line has the same pressure all the points, but Q pressure is less and the P pressure is more. Understood? Now I will try to find the pressure difference, how it is. Copy this first. Later I am explaining this side, the pressure difference in this acyclic fluid, right? For example, right, although the angle we have found in this way, right, and suppose whether it is open or closed does not matter, right? If these are the 2 points and the water is filled over here, suppose this is the open, right? So the definitely the surface become horizontal like this, and if these are the 2 points, right, point 1 and the point 2, listen one thing, in the other way the equipressure line will be like this, right? First of all, I had explained it has the maximum pressure. Suppose this is the point 1, this is the point 2, and this is the point 3. Is it clear? Suppose this is the height h and this is the length L, right? Listen one thing, very easy method I am telling you to find the pressure difference. These 2 points vertically, if you consider any point in vertical direction, what is the force? Say mg. Is it clear or not? say mg. And in the horizontal direction, what is the force with respect to this if it is accelerating a? So when you will move down, when you will move down, who's increasing, who's exerting the force? Say mg, right? So what is the difference between P1 and P2? You tell, which is greater? Varsha, say P2 is greater. By what amount? P2 minus P1 is equal to h rho g, because the acceleration is g in this direction. Fine. And what about the P3 and P2? Listen, the force acceleration is acting, force is acting in this direction. P3 is greater than P2. By what amount? You tell. Say the h mean the separation, L rho, and what is the acceleration in this direction? Say A. Is it clear or not? You tell. So if this is P and this is Q and the distance between them is x, and this is the acceleration A in this direction. So Vp, pressure P minus pressure Q is equal to what? Say h rho g I will apply, all h rho A, h rho A I will apply. If it is g, then I put g. If it is A, I will put A. So what is the difference? X rho A. That's it. So this is the pressure difference between these 2 points. Is it clear or not? So if you are increasing in this way, the pressure is increasing due to the acceleration g, right? And if you are moving in this way, the acceleration is increasing by this amount. Is it clear or not? You tell. One more thing. Suppose there is a water, right? Surface I cannot say, but it is accelerating A1 in this direction, and this is accelerating in the upward direction A2. Is it clear? And you are sitting over here. Suppose the water is filled. The surface may be anything like this. So you tell me between point 1 and 2, suppose this is the height h. What is the separation is h. What is the pressure difference? You tell. If you consider any point, what is the force with respect to this? You are sitting on the tank. The acceleration is A2, vertical, also horizontal. So if you consider this direction, G plus A2, so P2 minus P1 is equal to H rho. Rho is the density, and the acceleration, effective acceleration, G plus A. Is it clear or not? And if you consider the third point, suppose this is a separation x, it is A1, so MA1, right? This is what? Say M G plus A2. Are you getting or not? So what is the difference between P3 and P2? X rho A1, and this is A2. You are getting this point or not?
Yes.
Can you tell me what is the angle alpha in this case made by this equipressure line with the horizontal? Can you get this answer in the same way as I have done in this case? How to find if this is the fluid accelerating horizontally A1, accelerating A2. A1 and A2 are the acceleration given by us, and the G is acceleration, mg is the force exerted by the earth itself. So if you want to find this angle alpha, what is the way? You consider any point, you sit on this non-inertial frame of reference with respect to this is the surface. The force acting in this direction is what? Say mg plus A2. In this direction, ma1. So if this is alpha, right, the resultant force is this, which is perpendicular like this. You can make little beautiful picture, mg plus A2. If this is alpha, 90 minus alpha, this is alpha. So what is the tan alpha? Please tell Varsha in this figure. What is the tan alpha? Tan alpha is equal to mg plus A2. So this is the alpha by the made by this surface with the horizontal. Even if it is accelerated in x and y direction, you can do in this way. Sit on this case. If acceleration is a1 in this direction, apply the pseudo force. Mg will acting in this direction always. So the force is acting the perpendicular direction. That is why the equipressure lines are like this, and this is the maximum pressure point. Right? Copy this. So I'm giving you one question. Suppose this is the U-tube, right? And the water is filled like this at the same horizontal level. Fine. If it is at rest, the horizontal level will be the same. Is it clear or not? You tell. If this is the length L, you can assume, right? If this is the point 1 and the point 2. The hydrostatics paradox says that at the liquid at rest, the rest or the non-accelerated fluid, the pressure is same at the same horizontal line in the same liquid, right? So what is the relation between P1 and P2 if it is at rest? Tell me. You will, P1 is equal to P2. Now if it is accelerated, it is accelerated right with acceleration A, right, like this. Is it clear? So what will happen? Which pressure will be greater if it is accelerated A? You tell. Yes, P1 is greater than P2, no doubt. P1 is greater. When the P1 is greater, so what will happen? The fluid will be no more on the same horizontal level, right? Rather, the fluid will rise in this level and it will be more in this level. If it is accelerating in this way, is it clear or not? And listen one thing, you have to find the height. If this is L, right, this is given L, right, the find H. I'm writing in short, right, because find H. Is it clear or not? This is the point. They will give like this only, no, they will give the right 0.1 or 0.2. In this arm the liquid will rise, in this arm the liquid will right down. And listen, the equipressure line will be like this. So although the water surface will be like this, is it clear? They may ask this theta also, they may ask this is the height difference also. Fine, if the acceleration is there. You understand the question? Right. So let's see. To solve this question, I will assume this is the point 1, this is the point 2. As I told you, the P1, you told me that P1 is greater than P2. And by what amount you can consider? By what amount the P1? Yes, tell me. What is the difference? If P1, yes, P1 minus P2 is equal to what? L rho A. That's it. And if you consider this the atmospheric pressure, if you consider this the H1, and if you consider the H2, you tell if it is P naught and P naught, because it is open to air, when you will move down, can you write the pressure P1 equation? P1 is P naught plus, you will say H1 rho G. Is it clear or not? What is the P2 at this point? P2 is equal to P naught, नीचे जा रहे हैं, we are going to down, and in downward direction only the force is mg. We are not moving left to right. Left to right we are moving from point 1 to right. So what is the P2? P naught plus H2 rho G. Is it clear or should I explain once again? Yes. So P1 is what? P1 is P naught plus H1 rho G, P naught plus H2 rho G is equal to L rho A. So P naught will cancel out. H1 minus H2 is equal to rho G is equal to L rho A. Rho will cancel out. H1 minus H2 is equal to what? Say H, G, LA. What is the H? Say LA upon G. This is the thing. So this is the height difference in the two arms. Also, if you want to find the tan theta, the one way to find the tan theta is what? Tan theta is H upon L. H upon L. And what is the H? Say L by G by L. So tan theta is equal to A by G. In this way also you are able to find the tan theta. Although I have given you one another way to find the tan theta, right? How? Because these are the equipressure line. These are the equipressure lines. Mg is acting in this way, right? Mg is acting in this way. Ma is acting in this way. This is the net force. This is the theta. This is the theta. In this way also you can find tan theta. Other way is like this, H upon L. The same answer you will get. Copy this. In this question also, if this is the B, this is the C, this is the A, this is the D, and if the length is L, if they ask what is the pressure difference, PA minus PD, what will you say? The acceleration is A, the length is L, A is greater than D, B is also greater than C. What is the answer you will write? But the pressure difference, say L rho A. Say L rho A. The pressure difference is same. You are moving in this direction, pressure is changing. Is it clear or not? Yes. Copy this, copy this. Please copy this fast. Then I will move to the next concept. Right. Listen one more thing. Another question of similar type. Right. For example, if this is the incline, right, and the smooth incline is there, and there is a tank. So if the tank is like this, right, tank is like this. Is it clear? Like this. Fine. And the water is filled on this tank. So what will you say if it is at rest initially? Tell me, Varshas. Water is filled. It is at rest. So water will be in this direction or not, you tell? Tell me. It will be horizontal. Why it is? When you will sit over there, only one force will acting. So these are the equipressure lines. Is it clear or not? Getting? Now if it is released, first of all tell me, if it is released, what will be the acceleration? What is the acceleration of the block? If very nice, very good. So g sine theta, right? So if it is released, right, the level will be the same or it will be changed. You have to tell. I'm not giving as a theory. I'm giving as a concept only. Right. If it is released, then what will be the acceleration? You have to understand g sine theta. Is it clear or not? Now you are sitting on this tank. Find if it is released. Then you tell me. If you consider a molecule, how many force will act? Please tell. With respect to this tank, tell me. Say mg. How many force will act? And acceleration in this side, the pseudo force will act upon this in that direction, not. Right? So this is the mg, a molecule I am considering. So the two force will act. This is the ma. And what is the ma? The acceleration is g sine theta. Is it clear or not? And mg is acting in this direction. If this is theta, you can resolve this. This is theta. This is what? Say mg cos theta. This is what? Say mg sine theta. Is it clear or not? So if it is released from rest, you tell me, what is the net force on a water molecule or any water molecule? What will you say? If it is released from rest, you are sitting over here, the mg and mg sine theta, this is mg and this is mg sine theta is acting only. And what is the resultant of these two forces? This is mg cos theta, mg sine theta, mg sine theta, mg sine theta will cancel out. So with respect to this, only the force is acting in this direction. And what is the force? Say mg cos theta. Is it clear or not? So what will be the level? The force or net force is acting in this direction. If it is theta and it is released and the acceleration is g sine theta, what will be the surface level? The surface level will be like this. Is it clear, Varsha, or not? Initially it is horizontal like this. Now this is the line mg sine theta. Are you getting or not? So what are the equipressure line in this case? These are the equipressure line. What is the acceleration by which the acceleration is increasing? Say g cos theta. So if this is the one point, this is the third point, suppose, and this is distance x or h, you can say. So can you tell me, if this is the P1 and this is the P3, what is the difference? P3 is greater than P1, P3 minus P1 is equal to h rho. What is the acceleration in this case? G cos theta. Is it clear or not? You tell. And sometimes they ask the angle. They ask this angle. So this angle is what? Say theta. Initially, the angle over here is alpha is equal to 0 with the horizontal. Now with the horizontal, this alpha become theta. And if they ask, due to some reason, the pressure difference, the pressure is increasing in this direction. Please make it clear, right? And this is the relation. I think you are getting the concept how the pressure is changing due to the acceleration. Not always h rho g, h rho g. If this is the accelerated fluid, the pressure may be changed, right? That is the concept. Please copy this. So now the next concept, the rotating vessel. Rotating vessel, right? In the rotating vessel, suppose this is the bucket or the tank, and the radius of this tank is supposed to be capital R. It is at rest, right? So when it is at rest, what will you see? The level of the water is what? Horizontal. If it start rotating, right? If this fluid start rotating with some angular velocity omega, can you tell me what will be the shape of the water level? The water level become like this, like this. Is it clear or not? It is rotating with angular velocity omega. This surface is parabolic like this, right? Initially it is horizontal. When it start rotating, you can see the water become like this. Is it clear or not? Right? So you tell me, if you consider, right, this is the line, right? This is the line, suppose. You consider any line, this is the line. This is the H and this is the H1. So as you are moving away from the center or the axis, this is the height is increasing. Although you will remember this is parabolic surface, the surface is parabolic. I will explain this also. The pressure is increasing. So you have to find the pressure difference between this point and this point. Also you have to find, this is the extra height. So many things. Also you have to find the equation, so that this surface is the parabolic, and find this equation. If it is the y-axis, this is the x-axis, like this. So to find all these things, what will you do? First of all, you must remember that the pressure is increasing, right? Because the height is increasing, that is why the pressure is increasing. So at distance x, you consider the element portion dx, and the mass of this portion is what? Say dm, and it is also rotating. as the pressure is increasing, you tell me the pressure at this side, the pressure at this side is P. After elemental distance dx, the pressure on this side become P plus dP. Is it clear or not? Right. And if this is the elemental portion, I'm considering this is the elemental portion over here, right? And suppose the area is A, the area is A, suppose. So right, so the force is acting in this day, force is acting F1 and F2. The pressure, the force is P plus dP into area. The force F1 is P into area. So which force is greater? Because the pressure in this side is greater, the force is greater, and this portion is rotating with this axis. So if this small element is rotating in the circular path, right, it is rotating with angular velocity omega, so the net force toward the center will provide required centripetal force. Net force towards center will provide required centripetal force. Can you tell me what is the net force toward the center? If this side is pressure P and after distance dx the pressure become P plus dP, F2 minus F1, net force is F2 minus F1. And what is the centripetal force? Is equal to mv square upon r or m r omega square. Is it clear or not? What is the F2? P plus dP, A minus P into A is equal to dm. What is the dm? Dm is equal to volume into density. Volume is A into dx into rho. So I'm writing dm is equal to what? A dx into rho into x omega square. Is it clear? So minus pa, A into dp is equal to, this is A rho omega square x into dx. A will cancel out. So this is the differential equation we are getting, right? Or sometime dp upon dx is equal to rho omega square x. It is written. The variation of the pressure as a function of x. Now, if you integrate this, rho omega square x dx, is it clear or not? So, for x is equal to 0, here, the x is equal to 0 and x is equal to x, any point. If you consider x is equal to 0 at this surface, is it clear or not? So, x is equal to 0, what will you consider? The pressure is atmospheric pressure, and at any distance x, the pressure is P. So P minus P naught is equal to rho omega square, the integration x square by 2 from 0 to x. So the pressure is P naught plus rho omega square x square by 2. So this is the pressure as a function of x. The pressure as a function of x. P naught, this is P naught plus rho omega square x square by 2. This is the y is equal to, if you make the graph between the pressure variation and the x variation. At x is equal to 0, the pressure is P naught, and as the x is increasing, it is increasing parabolically, right? So the pressure is increasing parabolically. You understand this concept? Copy this. So listen one more thing. If this is the rotating vessel, right? This is the, if you draw, this is the pressure and this is the distance x. So this is the parabolic curve. Fine. If this is the radius capital R, what is the pressure at this point? Say P naught. What is the pressure at this point? Say P naught. It is open, right? How does the water equipressure line in the, you tell me. If somebody asks what is the pressure between 1 point and 2 point, what is the relation view, what will you say? Varsha, are they same or they are different? Different. So P1 is greater than P2 or P2 is greater than P1? Very good. Why? Because the next equipressure line will be this, and this P1 and P3 will be the same. This is the one thing. As a function of x, if somebody asks if this is the P as a function of x, what is the pressure? I found the pressure is at this point is P naught plus, you have to remember this data, half rho omega square x square. Is it clear? So can you tell me at the edge at x is equal to r, what is the pressure? You tell. P naught plus half rho omega square r square. Is it clear or not? So if this is the point 2, if it is the point 3 and this is the point 4, which pressure is greater? You tell. P3 or P4? P4. P4 is greater because away, moving away, increasing. So at this point, when the x is equal to what? Say r. So what is the P4? It is P4 or not? You tell. Yes. Sometime they may ask the pressure at the edge is given by this. Fine. And what is the P3? You will say it is P naught. Is it fine or not? You tell. Right. So they will ask what is the height obtained by this. What is the height raised by the liquid on the edge? So how would you find? Listen, if this is the P naught, this is the P naught, also the P4 due to the mg, right, due to this liquid column, P4 is maybe written as P naught plus H rho into G because the weight is acting in this direction. Is it clear or not? So yes, the P3 we have to find this P4 minus P3. P4 half rho omega square r square, right? Or you can write only this is the P4, right? P3 minus P4 is equal to half rho omega square r square minus P naught. So this is the one relation they may ask, P4 minus P3. The difference between these points, pressure is half rho omega square r square. This is the one part. The another part they may ask height. So the P4 is P naught plus H rho G. By this equation, we are getting P naught plus half rho omega square r square is equal to P naught plus H rho G. P naught will cancel out, rho will also cancel out. 1 by omega square r square is equal to H into G, right? So what is the height? Omega square r square upon 2H, 2 rho. This is the height raised by the water level on the edge, right? P4 minus P3, and this is the thing. Is it clear or not? Copy this.